In this video, we're going to talk about the data structure called queues. Okay, so a queue in some ways is the reverse of a stack. If you remember, in a stack, we usually view it like this. And as you add items from the front, you're able to remove them from the back. So this one was the last in. So a stack is a last in, last out. Okay. Where a queue in England is just a line. So you queue up at a movie theater or whatever. So in this case, the difference is we usually represent this more linearly. Okay. The first in, so if this is the first one in, okay, so you're adding here, you're also exiting from here. Okay, so as you add other elements into here, it's always so you're adding from the back and taking out from the front. Okay, so it becomes a first. So again, we're at queue, a first in, first out data structure. Okay, and like before, our queues can be represented either as an array or as a linked list. Okay, we're going to talk primarily about the array part. Okay, so unlike when we were dealing with stacks, stacks made it relatively straightforward in that we could keep the stack top somewhere. Okay, and if the stack top are pointing here, when we would add an item, so that if this from our other implementation, the stack top would be here and our last item would be there. And it'd be easy enough to remove that item and you still would have this as the intact. So you always had something over here, which is the first item that you'd entered. Okay. So when we're dealing with queues, we have kind of a different problem. Okay. And it's the idea, say we're going to add, an X, a Y, and a Z in that order onto our array for the queue. Okay. When we get rid of something, okay, we're going to get rid of the X, not the Z. Okay. So that's left a hole in our array. Okay. So we do W, J, K, whatever we're adding. Okay. We have this unused portion. Okay. And if we take off a couple more items, you'll see very quickly that we're limiting the amount of space that we have for the array. Okay. And since arrays are of a fixed size, we can get to where we're all the way at the end. Okay. So if we added here, W, X, Y, Z again. Okay. This would report as our queue being full when there's all this room here. Okay. So we have to find a way to deal with this. Okay. And it turns out the best way to deal with this is basically to have a circular array. Okay. So we're going to have some pointer to the queue front. That's just an integer. That's the index position in the array. Okay. And you're also going to have a pointer to the queue rear. Okay. But we're going to do a mod on this. So if we want to add a new item here, they get added at the end, so it would be added here. We're going to use the mod function. The mod gives the remainder. Okay. Based on the max queue size, which will then point the queue rear over to there. Okay. And we can add our next element there. So that's the basic idea. Okay. That's how we're going to store it. So as before, we're going to create this queue abstract data type where we're going to model the functionality of a queue that we can then, it's going to have pure virtual functions. We're then going to be able to implement it either in arrays or in linked lists. Okay. So let's look at the functions that we're going to need. Okay. So they're just some utility functions. We have our is empty queue. Okay. This is going to be a Boolean function. Okay. It's also going to be, these are all going to be virtual. So let me, I guess, write these a little bit better here. So we have a virtual Boolean function is empty queue. Okay, which is, it's a constant. and equals 0 to be a pure virtual. Okay, and that's our normal. If the queue is empty, then it's going to return a true. If it's not, return false. We also have this full queue. We have initialize queue. Okay, none of these 6 parameters. Okay, and then we have the more useful ones, I think. Okay, we have the front function, which is going to return the first item, first element of the queue. Okay, so again, that has to be that the queue has to exist and it can't be empty for that. Okay, we're also going to have a back, which is not strictly speaking in the definition of a queue, but we have that anywhere anyway, where it's going to return the last element in the queue. Okay, we have an add queue function, which will take something that it then adds to the end of the queue. Okay, so it's going to add to the end of the queue. Okay, and then finally we have a delete queue, which will remove from the front of the queue. Okay, so that's the basic idea there. Okay, so again, for this operation with the arrays, okay, we're going to have to keep track of the following. And I'm going to go ahead and stick on the whiteboard. So we'll talk about how we would do this in a linked list. I think it's a little more straightforward before we go to the example of the arrays. Okay, so we're going to need this max queue size. Okay, that's an integer. We're going to need an int on the count to show how many elements are there. Okay, an int for queue front. Okay, which will track the position of the first element. An int for the queue rear. Okay, and then finally, whatever type we have, a pointer to an array called list. Very similar to what we did in the stacks. Okay, so we'll look at the code in a minute, but let's talk about the linked list implementation here. Okay, so as before, advantages here, the disadvantages first are that it's a little more complicated in some ways. But in this case, I'm not sure that it is. The advantages are that you have an unlimited size just based on the system memory, so unlimited for practical purposes. Okay, so for the linked list one, okay, we're going to basically have our linked list with our queue. Okay, with whatever data is there. So that's our linked list. It has 3 things here. Okay, so when we add the queue, okay, add is going to add over here. Okay, which means we're going to have to keep a pointer to the rear and a pointer to the front. Okay, so at the rear, when we add, it's going to add 1 to the rear. Okay, it's going to create a new node just like you would expect. It's going to reroute rear link to this new node, and then we're done. Okay, the delete node will take from the front. Okay, so it will just route the front to the front link, and that should take care of that. So that's pretty straightforward, and I'm not going to look at that in code. Okay, but I do want to look at the array in code. Okay, so we'll switch over here. So they're all together. Don't need that anymore. Okay. Now we can share instead screen here. Okay, so this out we're here. Okay, so we start with our abstract data type. Okay, it's what I just did on the whiteboard. We'll take a look at it anyway. So this is the queue. ADT header file. Okay, so again, as my is empty queue, is full queue, and then my initialization. Okay, that's a bool, and a void. Okay, they're pure virtual, the virtual keyword and equal 0, which means that there's an obligation that anything that inherits from the QADT has to implement these functions with the same signature, same return type, same number of type of parameters. Okay, so we then have the front, which will return the element that's at the front of the queue. Now, since this circular here, remember that it's possible that as far as the index number of the array, that your front could have a bigger number than the rear if it slid slid back around. Okay. So for that, when the queue must exist, can't be empty. Same restrictions on the back, which is going to return whatever's at the back element of the queue. Okay. Those make no changes, so they're constant functions. The add the queue is going to add something to the queue, so the queue must exist. It must not be full. Okay. And it's also a pure virtual function. And then we have the delete queue. The delete queue will remove that first element. So again, you're adding to the end of the queue, which means we have to keep track of that pointer. And then we're taking away from the front of the queue. Okay. So we're going to include that in our QArray.cpp file. Okay. So I'm going to go ahead and put a test in here. Okay. Again, you could just include this as well. If you include this, it will automatically include the ADT since this file includes that one. But we're just going to do the test in here for now. So I'm including the IO stream. I'm going to use the cassert again, which we'll see that in a minute. If it's empty and we're trying to get something from it, we're just going to have a fail. You may or may not want to do that, but we'll certainly, that's certainly an option. And then of course I have to include the QADT that we just did. Okay. So, and using namespace standard just to avoid having to put standard : everywhere. Okay. So we have our template class type here. Just so this is a templated data structure, we can have a queue of integers, a queue of floats, a queue of whatever we want. Okay. We can even have a queue of objects of some other type. Okay. You could have a queue of stacks if you want, which should kind of hurt your head, but it certainly could be done. Not recommending it. Okay. So this class QArray then is going to inherit publicly from the QADT, and we have to send along this type parameter. Okay. So the QADT is typed, so the QArray has to be the same type. And that's what we're doing here. Okay. And then as far as this is what we just talked about before, these are the things we have to keep track of. We have the max queue size, that's the biggest the queue can be. Okay. We're going to use that again in our modulo calculations to wrap around and go back to the beginning. We're going to have a count, which is the number of items that are in the queue. We have the position, it's not a pointer since it's not a linked list. We have a queue front and a queue rear, which are the integer indices of the list array, okay, for those positions. And then we have the list array itself that we're calculating. That's of type, big T type, okay? So a lot of these, as with the stack, are pretty straightforward. The isEmpty queue, we're just looking to see if the count's equal to 0. If the count's equal to 0, it's empty. If the count is not equal to 0, it's not empty. So that returns a true or a false, okay? We also have the is full, depends on whether or not the count is equal to the max queue size. If count is equal to max queue size, then you're full. If it's not, you're not. So we return those, okay? When we initialize our queue, we set the queue front equal to 0, okay? The initialize will return an empty queue, basically. So that's what that's going to set there. The queue rear then becomes the max queue size minus 1. Okay, so we've got the whole space available for the queue there. Okay, and the count is equal to 0. No, sorry, max queue size minus 1 is going to take you back to the front as well. Okay, so and the count's equal to 0. Okay, the next function we have is the front function. Remember, that's going to return the position that's at the queue front. But again, we're doing the assert here. We're asserting that it's false that our queue is empty. So not is empty queue. If not is empty, if is empty queue is true, then not is empty queue is false. The assertion's false, and it will blow up. It will not continue. Okay. But if it's not empty, then we can return the list at that position of queue front. Okay. The back function looks almost identical, except we're doing the queue rear. Okay, so nothing really new or different there. Okay. The add queue, we're going to take again something called new element. New element is not going to be changed by this process. We're adding it to the queue, so it's a constant function. Okay, so first we're looking to see if the queue is full. If it is, we're going to give them an error message. You can't add to a full queue. Okay, but if it's not the case that it's full, then we're going to set our new queue rear equal to the old queue rear plus 1. Okay, then we're going to mod that by the max queue size, just in case we go past the end, it'll wrap back around to the beginning. Okay, we're then going to increase the count by 1. Okay, we're then going to set the list at that queue rear, we're adding at the rear, to that new element. Okay, so again, we need the count in this case because we can't just, if we knew we were never going to wrap around, we could look at the index position in the array of the front queue and the rear queue and determine from that the count. And in general, you don't want to store stuff that you can calculate. Okay, but because we're wrapping around, that count will not be easy to determine. So we're just going to go ahead and keep a count variable in there. Okay, so that's what the add queue does for us. We then get to the delete queue. The delete queue, again, it's going to check to see if it's empty. Okay, if it is empty, we're just going to say you can't delete from an empty queue. If not, we're going to decrement the count. There's now one less element. Okay, and since we're deleting from the front, we're going to move the queue front 1 to the right. So I'm going to add 1 to it. Again, modding it on the max queue size in case it goes past the end, which it may. Okay, that's all we've got there. As far as a constructor goes, it's going to set things up. So it's going to take, we saw this before, similar things as we saw with the stacks. We're going to take an integer for the queue size. We could add a default there if we wanted. We could put a, equals 50, whatever, if you want, but we don't need to. Okay. So then we're going to say if they give us a size that's less than or equal to 0, okay, then we're going to put a message that the size of the queue must be positive, and we're going to default to 100. Okay, so that will set the max queue size to 100. Else, we'll just set the max queue size to whatever integer they gave us to the queue size. Okay, so once we have the queue size, we're then going to set, as we did before, on the initialize, the queue front to 0, the queue rear to the max queue size minus 1. Okay, the count equal to 0. Okay, and then the list, we're going to create here our new, the list will be a new array of type at the max queue size. Okay, so that should be that. And again, I think I misspoke before. What this is setting it to the end position, because when we go to add one, so again, we're at an empty queue. So the max queue size has to be at the end. So when we increase it by 1 to add 1, we're adding it to the proper position. Okay, so if our max queue size is 100, okay, we want our initial max queue size to be at 100 when we start, when it's empty. So when we add 1 to it, which we normally do as part of our insert. So let's look at that add queue to see what that's happening. Okay, let's go back to here. Here's the add. Okay, so again, when we're adding the new element, we're increasing this queue rear by 1. Okay, mod the queue size. So we want it to be at the end, so it will point back to the beginning. We're doing that before we add. So if we left this at the beginning, like we did with the stack, if you went the front and the rear to point to 0 both times, then we would never add the 0. We would start adding to the 1. Okay, so that's why that happens. Okay, looks a little strange. Okay, there's our constructor. Okay, note that I'm not putting in here the overriding of the equality of the assignment operator, the equal sign. I'm also not looking at the copy constructor, but those are things that need to happen. Okay, so here's where we're going to create a new queue array typed int, calling a queue with a size of 50. Okay, this needs to be tested more, but this gives you the basic idea. I'm then adding in 5, 15, 25, 35, 45, and then I'm printing out the front of the array and the back of the rear of the array. Okay, which we can do, but you should also do things like add to the, we're doing that queue. We still need to test the delete queue. We need to test the initialize, all those other functions. Okay, but that's straightforward enough to do. I think I can leave that to you, leave you to your own devices on that one. Okay, But that's the idea. We can just check this out, make sure it works. There we go. The front of the array is 5 and the rear is 45. Okay. And again, the way to move through an array is to pull from the front, add to the rear, pull from the front. Okay. So the other things just to talk about, and I'll go ahead and pull up this code is while we're talking for no particular reason. The standard template library does have a queue class. There's a queue container that you could use that has a size, an empty, a push, a front, a back, and a pop. Okay, so you can certainly do that if you want to do that. The other thing that you sometimes see that we're not really going to talk about due to time constraints is the idea of a priority queue. Okay, so a priority queue is going to be a queue where it's not necessarily the first in, first out, that there are classes of things. Think when you're getting on an airplane, you know, if there's business class and first class comes first, business class comes first, and then everybody else comes second, and everybody else comes third. So similar to that. Or also if you're in the emergency room, they typically take the first person that comes in, but they divide you into classes based on your condition. If you're in an emergency condition, then you go to the front of the line. Okay, so that's the idea of a priority queue. The priority queue is going to have an additional piece of data with every element, which is the priority, and it's going to basically take everything from the lowest priority or highest, depending on how you do it, before it goes on to the next queue. Okay, so that's another data system, a data structure that you see sometimes. Okay, but not really going to go into that much more. Okay, so that, again, that's the idea of queues. So we've now talked about the 3 different data structures. Okay, well, we hit arrays are a data structure, but the new ones for us first with a linked list. And the linked list has the advantage over the arrays that it's unlimited in size, only based on the memory of the system you're running on. Okay, but it's a little harder to handle. We have to manage things ourselves more. Okay, and then we use the linked list to build 2 other really important data structures. And that's going to be the stack, which is our first in, last out data structure. And it's going to be our queue, which is our first in, first out data structure. Okay. And again, both of those can be implemented either in arrays or in linked lists. And you have pros and cons for both of those. Okay. So from here, we're going to be moving into searching, how we can search on these data structures, and also some hashing algorithms. The hash is another important data structure that we're going to talk about. Okay. Then after that, we'll talk about some sorting algorithms, because sorting is also an important thing to do. Okay. So if you have questions on this, make sure that you let me know.